All right, for our distinguished panel, the three of our earlier speakers, business analyst and thought leader, Mr. Barry, Mr. Fitzgerald, who has led projects larger than the space elevator projects, and nuclear physicist Dr. Wright, will be joined by Bill Britton. Mr. Britton is Vice President of Information Technology and Chief Information Officer at California Polytechnic State University. During his tenure there, he has built the California Cybersecurity Institute into a nationally prominent educational and research facility. From the inception of cyber and throughout his career with Cal Poly, at Parsons Cyber, and as an intelligence and electronic warfare officer with the U.S. Air Force, Mr. Britton has been on the forefront of developing and implementing new cybersecurity concepts. Go ahead and get started with the panel.
And Lee, thank you for that very generous introduction.
It was easy to be glowing about you guys.
Thank you, Leah. This has all been exciting for me because I've been dreaming on it, sleeping on it, worried about it, and frankly, I recognize the doability of what has been presented today because we know the path we're on and the path, the destination to where we're headed. I'm going to oversimplify what we said today. All right, the engineering and economics of a space elevator are obvious. But let's take a look a little bit at what else we need. My favorite story here is I was once invited in to be a part of a missile system. It was a very large project. And I walked into the conference room and there were two generals and three colonels all looking at stuff on the table there, and I said, aha, they're talking about strategic warfare or whatever. No. What they were looking at were the files, if you will, of ROTC officers in college, because they knew that the critical design review of this missile thing that I was getting involved in was 8 to 10 years away, and we needed X number of people to build it, test it, and make it work. And that's the tone of what I want the panel to do. Now, on the next slide. In simple talk, let's, by premise, say that's the engineering concept and include the alternatives that were mentioned today. Now let's look at the future. Next slide. And this is the who that have, I'm just going to sit back and listen. Bill Britton, Kent, and Dennis Wright. Next slide. Go to the next one, please. Is we have to match up the 5 or 6 forces that are going to make the space elevator and space infrastructure in general. And I played a little trick here. Is because I don't know which way the thrusts are heading, so I'm calling, as Bill Britton will call for, and Kevin Barry will call for, and Dennis Wright will call for, to reverse engineer back from the vision to figure out what we need in terms of education, a workforce, a business basis, and Dennis Wright, research and engineering, my friend. I'm going to offer the first moments to Bill Britton, and the other two interrupt when you got something to say.
I'm expecting lots of interruptions then. First, I want to thank everybody for setting us up the way that you did throughout the day. And I asked a couple questions, and they were primarily always the same, which is around why now? What makes sense now? And I think what was laid out is a really good conversation around the why. In the operations world, which is where I come from, there's an old joke and adage that the engineering team clears up what the scientists thought that they had fixed and designed and built. The engineers then get to design it and build it and put it into play. And the operation team clears up and cleans up everybody else's mistakes. So that's kind of the context for where I'm coming from today, which is this operation side or workforce. And I think that we learned something very significant throughout all these other major programs they've talked about. And the size of the workforce was a smaller entity in those days. It didn't take as many people to make things happen and go. and small strike teams were able to make these things happen, and they grew over time. I don't think we have that luxury with where we are at right now. This is going to explode, and you're going to require a workforce on the job, trained and knowledgeable from the get-go. Now why? I think the reason is because, as they pointed out, so many of these technologies are already known today. They're already understood. It's no longer the art of the possible, it's the art of the doable. And so as such, you've got to take those differing talent pools that have been using that technology for other resources, and you have to educate them first to talk to each other, to work collectively, and then to understand what it is they're now trying to do with these new ways of using the technologies. I see three primary technologies as a core element, no matter what you do in this business, that we really haven't even discussed today, but I think they're important. The first one is the knowledge of digital. Everything we talked about today has a digital component to it, interacting, relying upon each other, really working as a collective. So the digital, everything from how do I get people from point A to point B? How do I make sure that as it goes up the elevator, there's nothing in space, debris? This is all digital data. Data correlates to the need for compute capability. The compute capability is now a major requirement to sustain this entire infrastructure operation. So how do we do that? Do we wait around? No, we have the capability today in cloud. So understanding how cloud is corollary to this new emerging infrastructure, using those cloud skills as it relates to the support for this digital community, this digital support structure. Now, embedded in both the first and the second, in digital and in cloud, is also the reference to cybersecurity. Space Force has made it a mandate that all of their programs have cybersecurity built in up front. There's a reason for that importance, and it's something that needs to be corollary. So every engineer, every person working on the space elevator concept needs to understand the digital cloud cyber arena. Now, getting that kind of workforce just doesn't happen overnight. So there's an entire requirement to really start re-looking at re-energizing the support structure. And I'm not saying that universities and structures aren't capable of providing for the future, but if you really want them to be work ready for this environment, you've got to start changing that paradigm to match up. A lot of the principles that Fitzer talked about, he and I learned through the School of Hard Knocks. And as an operator, that's when he threw a wrench at me because we had dropped something accidentally on the floor. And that's going to have to happen. And what we want to do is try to reduce that as best we can in that educational experience. I saw the reference earlier to someone from the DC area with University Mars. Those are great concepts, but the question becomes, how do we make non-traditional education as well as traditional education important and computing elements for the future of the elevator? More importantly, how do we get people with tech degrees, certs, and 2-year programs involved? We can't have all PhDs and astrophysicists running the elevator. So somehow we have to find this workforce and create them ready, willing, and able to support. And this goes back to Kevin's point about the infrastructure, the economy build, all these changing elements and how they have to be focused. And I think, again, in this environment, we better start early and start often.
Yeah, and just kind of leading right off of that idea, Bill, I agree with all the things you're saying. And, kind of one of the aspects that I think is necessary to really push this forward is a greater level of market liquidity that recently we've seen in the venture capital world, a rather exponential increase in the amount of capital flowing into the space sector. 2014, it was only $200 million, and now it's in the billions of dollars a year flowing in. 2020 was a banner year, but on the scale of private equity, that's peanuts. I mean, it's a very limited pool, even though we have 1/7 of all the venture capital funding in the United States is already going towards space and space startups. And that sort of making this transition in the infrastructure to the financial infrastructure, both government and private liquidity is really important. That in many ways, one of the driving factors of infrastructure throughout history, and especially the Dark Ages, were in many ways the Dark Ages specifically because the Christian Church basically outlawed any usage of interest, and that stifled investment and the ability to expand into these new rich value areas and take out a loan to build on something in the future. And that when that was reinstituted starting in Spain, it very quickly led to the Renaissance and to the development of new ventures, exploring the new world, colonization. All of that stemmed from this increase in financial liquidity. And one of the biggest obstacles that we're facing right now in terms of building up this infrastructure and getting that economy rolling, getting those students not just trained, but giving them jobs. So we don't have something like Arab Spring where you overtrain and under-deliver on the jobs. You need to be able to have the economy behind it, and you need to have the financial liquidity to fund those investments.
Yes.
And right now, space, for better or for worse, is still kind of seen in this woo-woo science fiction. Like, it's not taken as a very serious financial investment, and that a greater growth in using tools like in international development of blended finance to help improve risk-adjusted returns, employing government capital as collateral, are all very useful tools in helping to push this forward, so that all these different small enterprises and even the much larger corporations like Lockheed and Northrop can take and better utilize
Bingo. Yep.
the flow of money to create those jobs and to create those business opportunities and everything we've been talking about all day today. There's more than enough opportunity and value here that you can create an unending number of jobs from this with sufficient leverage.
I'd like to.
Dennis Wright, can you jump in here and talk a little bit about how research and engineering initiatives can address what Bill and Kevin have just alluded to?
Sure. If I might respond to what was mentioned before concerning education, and then I'll go into that, Fitzer. I think what we're going to have to see in the educational system is more hybrid degrees, let's call it that. So I noticed that David Dotson has a degree in computational physics. And I ran up against this particular problem when I was at SLAC. Is that basically you either had a degree in physics or you had a degree in computing. And the two did not meet, and the two camps did not talk to one another. And yet that was a primary demand for doing the simulations in high energy physics and nuclear physics. So it looks like that field is starting to emerge, but I think it will be critical for the space elevator. So we'll need somebody who does the physics and does the computing both. And
has somebody who very recently has gone through doing undergraduate in engineering physics, getting my master's in real estate development. I can say that while that does sound nice, there is a transition process of getting those people with combined degrees into adequate jobs, because it makes for a very mixed message.
Right.
And while I certainly would more than agree with you on the utility of that generalist role, so much of the way that our workforce and stuff is hiring favors much more specialization, especially early in your career, which kind of makes that effort in greater education and better understanding to be a luxury rather than a desirable path.
Yes, and now to get to Fitzer's suggestion about the research and engineering and how that would impact things. One thing that we're coming up with now in our study is that we seem to be opening up a kind of a region between molecular modeling and modeling of materials in bulk. And the experts in our group say that we don't know much about that area. And we could conceivably be opening up an entire new area of research. But if you can understand how to do things like take molecular forces and then build those into a prediction of the coefficient of friction and things like that, I think that's would be a tremendous advance, not only in research, but in engineering, because then you don't have to test things at first. You can put it into the computer and let the computer do that. And then you can build your engineering models. And so we can do a lot of the rapid prototyping if we have a better research idea of what these basic things are. And I think the more we look into things in the space elevator, especially at this interface between the molecular, the microscopic and the macroscopic, That I think that's the future for research, engineering, and education.
Hey, Bill. Bill,
Yeah,
you
go
and
ahead.
I worked in a time frame for education with industry. Comment on that when your turn comes up.
So again, Dennis, you hit the nail on the head. This is an all-encompassing, not one area, not one specific. And this is an area where volume is important. The other concern that I have, and one of the nice things that EWE that was referred to, is it took people who were operators and it gave them an opportunity to understand how the industry worked. So it really gave them dual purpose. And I think this is something in this future workforce we're going to have to look at. If you're working on the moon or somewhere else and you have one job that you're doing, I don't think that's going to be sufficient in the future. You're going to have multiple roles and multiple things that you are doing. So your ability to, do basic reverse engineering is going to be critical. And there's some real attributes that you have to have that we kind of focused. I've got the gray hair too, so I can say it. We focused more in the past on, and we need to revitalize in the way that we think about educating and moving forward. I think, Kevin, your point is dead on, that all of the funds necessary drive the volume, which gives us the choice, the larger choice of people to do things. In a response to Martin here, I referenced, right now in just cybersecurity alone, there's over 650,000 openings for cybersecurity professionals in the US, 650,000. We're not meeting the demand there. Now, are all of them need to be 4-year degree? No. So part of the problem is really understanding, what does your workforce necessity look like? What is it? Where do you need them? And what are the skills necessary? So back to Dennis's point, which is really, if I understand what I need them to do and can educate so they have a basis, and then spread that out over multiple different areas, but that takes focus, right? That takes a hybrid approach to doing things. And then you've got the concern of, do I make it too hybrid, which means I've really diluted the skill set necessary to support. So I think there's a lot of things that we're going to have to resolve here as we move forward in this particular workspace area. The other thing that's interesting in this environment, where would I go do hands-on learning right now to do these kinds of skill sets? Right. So the crickets are the right response. There isn't. So again, we're making up this environment as we go. That's an important point. So now again, back to Dennis, which was simulators, capabilities, cloud tool sets.
1240.
This is where it gets to be way more critical in understanding, so we can build those preliminary training capabilities and make them available to people at large. I just think there's so many cool things ahead of us.
Yeah, and I think that the diverse focus and attention to how do we build with a more data-rich environment is absolutely right on. I mean, Space Elevator aside, adapting to having that more, automation and being able to say, how do we ask the correct questions? How do we train that workforce is going to be really critical. And I think that the guiding piece along this is figuring out how to establish proper value change and figuring out how to make it so that we don't get an over concentration of wealth in, like, much as I think SpaceX is fantastic, I think that imagining a future where the SpaceX board controls the majority of humanity's relation with space is kind of a terrifying proposition.
Yes.
I think that there is a level of democratizing that space for the purposes of having multiple entrants is one of the very best features of the Space Elevator. That by reducing that transaction cost and lowering those barriers to entry, you allow a much greater proliferation of other players in the marketplace, because there are different niches that can be served by a space elevator that are totally separate and completely complementary to what SpaceX is doing for getting Starlink, for sending up the rockets, and really probably establishing that first reconnaissance base on Mars. That all of those things are completely they work together. This is not a competition against. This is a, how do we collaborate to go further and to do more and to reach out and utilize all of the immense value in space.
So I think there's been some really good conversation in the chat around how early do you start? And I would argue what we need to do is to ensure that in the future we have less people with gray hair on the panel. And the way to do that is to start engaging students earlier. So let me just explain to you what I mean and dive a little bit on that. So one of the things that we're doing at the university is we sponsor our students build a competition for the state of California around cyber. But for the last 2 years, that competition has been based in cyber in space. So last year's competition, that is our students at the collegiate level build it for high school and middle school students to participate in. Last year's competition was around a scenario that a commercial satellite was hacked and brought back to Earth. Due to the magic of Hollywood, since we're in California, the payload survived and the students were able to do forensics analysis on the payload. So here you have middle schoolers and high schoolers doing forensics analysis with Wireshark, with Autopsy, with other high-end technical tools, some of which are being used by the Department of Defense to protect our systems today, to evaluate what happened to a platform and figure out how it got hacked. Then they have to go downstream in the system and figure out where the networks influenced. Was there malware or malicious code that was influenced in the system as a result? The coolest part of this is to watch those students do this in a gaming environment. This whole competition was done in a competition using an AWS-based platform, Unity. The students were competing against other students. And at the end, we had students who came up to us and they said, I never realized cyber was in space. I never realized space could be so cool because it's like a game. It's all these different things that students learn differently. We have to find a way to make that learning capability, that excitement available for the generation that's really going to be running and supporting Space Elevator Future.
Mm-hmm. Yeah, and I think that infrastructure and the buildup of just supporting those families is super critical. I mean, even going back to the construction of the Panama Canal, one of the major differences and reasons that the American effort was so successful by comparison to the French effort largely was just the amount of industrial hardware they brought to bear, but they solved a lot of really complicated non-infrastructure problems, like just the prevalence of malaria in the water around the sites. The death rate was incredibly high there, and the lack of families that were able to be supported. So the construction of the entire city of Panama City was done just to facilitate housing the workers and their families, hospitals, all of the different parts of the economy that are necessary. That when we talk about developing a space economy, I've gotten posed the question before, what is the space economy? I'm like, why are you having a qualifier? Like, the economy is moving into space. That means you have to bring all of the economy with it. And that you need to be able to have those people who run the hospital, who run healthcare, who run schools, all the whole 9 yards, that needs to become involved and engaged in it, because that's how you change it. When we had all of the momentum swing that we had from Apollo, a lot of it was because everybody was paying attention to it. The United States as a whole kind of decided, we want to win this race. We're going to send more people to school. We're going to get people more engaged. We're excited about being, a rocket engineer as like one of the best things you could do. And that fervor and that belief in space was so important to driving it forward. Finance and engineering aside, just focusing our interest on it was critical. And I think that, moving forward here, what I'm thinking, as far as engaging the economics and workforce, is to really say, we need to engage the economy into focusing on space, because it's a good place to invest, because it's a place to expand, and humanity likes to expand into new places. It's how we prevented the French Revolution for 200 years, was expanding to the new world. And as soon as that stopped, French Revolution began.
It's an interesting thing that we talk a lot about infrastructure, and especially with its economic aspects. But to me, I often think about the scientific infrastructure. And one of my dreams is to see a space elevator which is instrumented at every kilometer of its distance. And perhaps with graphene-based Hall sensors, and rotating in and out of the Earth's bow shock and into the plasma sheath and all sorts of various poorly studied areas of the Earth's magnetosphere, we can get a real-time study or heartbeat, if you will, of the Earth's magnetosphere by the space elevator itself being instrumented as a scientific instrument. And we can think about all of the other scientific projects which become enabled by the space elevator, such as launching large research platforms that could never be launched by rockets. A lot of these things come to mind. So we consider the economic infrastructure aspects, but I think we should also continue to look at the scientific infrastructure, and that will certainly breed interest.
Oh, sure.
Yes,
And,
Dennis, you're touching on something I was trying to lead Bill into. When he and I were doing things that we don't talk about, we were actually sent into industry, not to spy on them, for heaven's sake, but to co-learn the process that industry was going through and compare it to our educational things. I think what you're suggesting, don't let me put words in your mouth, but let me try this, that you're suggesting that a fundamental part, as in responsibility of the space elevator, is to extend the boundaries of the space elevator into the scientific regimes that you're alluding to.
Yes, exactly.
By the way, I noticed that Tim I know you've been here all morning, but if Tim and Adrian and Pete Swan have questions, I know not one of you is shy, but go ahead and ask, because these guys deserve the questions.
Well, I'm never shy. Anyway, let's think about this. And one of the first steps we've proposed is the Space Elevator Institute. And what we need to do is address the issues. You guys just touched on the issues from cybersecurity to tech degrees. And, you know, I believe it's true. We got to have a whole bunch of tech degrees to make it happen. We have to have a bunch of PhDs to make sure we understand the science. But, you know, how do we get that involvement of the full range of education?
I think you have three factors. You've got a conversion factor that's converting people who do other things similar to this workforce. You've got a new start, which is how do I start training this, evolving this from zero, from scratch? And then the motivation to get the younger generation interested enough to come be in that zero start element. I agree with you. The academy, the concept of some place that is a designated place to go is good. But you have to be able to be not only a place to go do, but a front for sending the message out across the multiple educational entities.
Yes, and then education is great, and people learn all this stuff, and there are a lot of people who really like space and space elevators. But when it comes to having a career in space elevators, I think there are two people who are paid to do that work in the whole world right now, and so that has to change.
Yep.
I think that's what Kevin was getting at. Basically, is the whole evolutionary element, the correlation to the different facets in time and you know, industrial revolution, all those elements. Again, I hope we line them all up this time. That's all. It's just kind of a good time. Technology is there, cloud is there, all those things are there. As someone was saying earlier, you know, the format's kind of there already. We have to find a way to just plug it in. Well, I think it's more than plug, it's motivate them in. Get them excited about being involved and excited about learning and going forward, and then really taking it off.
Bill, you make an interesting point, just picking up from Dennis, that, you know, there's only two people in the world actually being paid for space elevators, and we're talking about the biggest construction project of mankind. And I think you're right. You made a point earlier that this thing is going to experience an exponential rise very, very soon and very quickly. How the hell do we all hang on?
Yeah, you know, I can go back as short as 5 years ago, and people told me at the CIO of the university, cloud is not going to take. It's just not real. It's only somebody's computer talking to another data center. Oh my God, what has happened in 5 years? Right? I dare you to name a major corporation who isn't cloud-based in some way, shape, or form, right? Even federal governments are cloud-based. It didn't take off, it exploded. That same technological leap is what I see for space elevator. I mean, again, all the reasons not to, you all have made it very clear today, those reasons don't exist anymore. All the reasons are there now to go do. So when that go do gets done, it will do, I think, very similarly to what cloud has done, which is to accelerate right through the roof. How do you prepare for it? We have got to focus differently than we did in cloud and differently than we did in cyber explosion on developing a path for workforce development now, as we are both doing the R&D and test evaluation, and be ready.
Yeah. And I think that I'm going to draw upon somebody else's analysis entirely, um, of looking at ARC investment, and particularly their focus on the use of rights law, and how as you get a growth in an industry, it's based on the number of units produced. So you get more units produced and the growth accelerates. And that we've seen, like in the falling cost of batteries, or even more so in genomics, this rate of cost reduction well exceeding even the rate of improvement that we've seen in computers, which is stupendous in its own right. And following, these kinds of patterns, so much analysis and focus is on these linear trends, because that is generally how humans evolutionary think. And even though we can do the math, and I'm sure everyone in this call is capable of doing an exponential, it is just not an intuitive way for humans to think, to imagine, as simple of a difference as, okay, I'm going to earn 12% interest this year versus I earn 24% interest this year. Over a 30-year time period, that's a difference of 32 times your money or 1,024 times your money. And that difference is so great that it's very difficult for us to work with. So when we're creating policy, when we're creating trends, to Bill's point exactly, we have to look at what is the data here? What is this exponential pattern? What are we actually seeing? And that if we plan for our workforce and our economy according to the data that we see, rather than our, straight line projections, we're going to get very different answers. And I think that just a little bit of a reframe to look at what those numbers really are, and to do that data, and, to Adrian's point, to start getting the seed money to do that analytical work and really dig in, to be like, okay, if space elevators are going to take off, if we're going to start to see, the scaling and the manufacture of single crystal graphene, how quickly is that going to happen? Based on our models, is it going to take 10 years? Is it going to take 15? Like, looking at what that curve looks like and the demand effect it will have on the marketplace, I think is an absolutely perfect place to start. And it's what I, sort of proposed in my panel, is that right now we're in the seed funding phase. And there's not a profit line at this point. I wish there was, but we got to focus on what is something we can show today, and start to get professionals and professional credibility to build these academies, to build this knowledge base up, because it is coming and we do need it.
I'll tell you one thing I'm observing as well is there's a heck of a lot of solid foundations being laid by ISEC and everybody else. The groundwork's there, and now I'm seeing, as well as the technology moving at an accelerated pace, Tim, the stuff you're doing is really important. You're accelerating the socializing around this and getting those messages out, and that's never happened before. And I think something profound will probably happen as a result of what you're doing.
Yeah, it seems to me that the demand pull is there. We were talking about all the different people who need stuff in space, but they don't know that their demands are so large. There are so many people that are dreaming and given visions, and we could do this and planning for this, but they haven't stood up and said, I need this movement. And so we need to have the demand pull stand up and start saying, I can't do space solar power without space elevators. Now we have Dr. Dodson there. David is taking on a big challenge. He's going to present a topic inside space solar power symposium in the IAF, assuming that paper gets accepted, of course. And he's going to stand up and say, you can't do it without space elevators. And that's a big step. And that's the type of thing we need to take on. And we need to have the ability to talk to the people who have the demand pull arena. So they step up and say, oh, yeah, we need to do this. By the way, to do this, we need space elevators. I don't know how to do that. If anybody does, send me an email, call me, Skype me, whatever you want to do. But we need to start thinking about that particular issue. How do we get acceptance out there and people realizing that they really need us? We know they need us, but we need them to realize they need us.
I think the key thing to that, Pete, is focusing on the smaller scale applications of the material. And so there was this discussion in the chat and in other places about discussion with Elon Musk and build me a footbridge, then I'll talk to you. Lots of other things like that could increase the public awareness that it is possible. And so
I endorse that. Yes. Yes.
100% agree.
Supporting civil engineering projects which use graphene or other strong materials, and much like the Eiffel Tower and the Ferris wheel were built to demonstrate that steel was safe and reliable. We need those things.
Well, maybe we could have an intern at the University of Manchester that gets tasked to build a footbridge with at least polycrystalline graphene, and does it,
Yeah, interesting you say that, Pete. We're not quite doing that, but Bill might be interested in this. The University of Manchester organises a graphene hackathon, and we're the publishing company. We sponsor that. We have done for the last couple of years, and now we're beginning to introduce sheet graphene into their thinking already.
Great.
So we're trying to get them playing with the material, thinking about the problems. Dennis, as you said, creating the small devices and actually seeing this stuff's possible. All the way up till now, it's all been powders. Now, in the last few months, we can see that people can get hold of sheet material and start playing with it. And Bill, gamification, that's really important too, just making things fun. Yeah,
Absolutely.
Oh, absolutely. And I would say just on this idea of the footbridge, I really like the optics of I think that so many people just have no conception of what a space elevator even is. Like there's lots of quotes in here of university professors being like, oh, actually your data is wrong. It couldn't be at that speed, at that height. It's like, well, it's not in orbit. What do you mean it's not in orbit? And just the basic understanding that it is a cable in traction has not perforated into even the academic community. And the concept of graphene, even more so. Like if you think about, what is a space elevator, like a tower to space, people think something more like the Eiffel Tower. They don't think of something like a freaking film of a bubble, little rainbow shimmery bifrost going into space that you're going to climb along this slippery film. And that's going to be strong enough to have a 20-ton climber just ascend on something you can hardly even see. And I think that, even if you can build this scale model of something, even at a small scale, that's going to make such a big difference and make people realize, because so much of the stumbling blocks and the hurdles we're seeing right now is just those technical demonstrations that Fitzer and Swan have both highlighted as fundamentally critical. I think that there's also a little bit of, I believe it when I see it, that engineering aside, people just don't think this is real.
Yeah. And it's also the researchers involved in graphene as well, Kevin. So that give you an idea about the problems we're facing, just getting the message out there. People are concentrating at the moment on graphene for electronics. And when you layer it up more than 10 layers, it becomes graphite and it loses its electronic properties. So what we're talking about is making large scale sheet graphene and layering it up and layering it up. And the pushback we're getting even from PhD researchers is, oh, well, you're just making graphite and it's going to lose all its properties. No, this is a fantastic new frontier material, and we're trying to get the scales to fall from people's eyes. So it's an uphill struggle, but we're getting the message out there and starting. But this is why the socialization aspect is so important.
I'm sorry, I'm going to jump in here for a second. Liftport was famous for our stunts. And yeah, there was science there, but I mean, you see our robots behind us. We did a lot of stunts, and that's how we got our reputation. It was a long time ago. It was more than 13, 14 years ago when we closed. But we did a lot of stunts, and they were very effective. We went out to MIT and we put a cantilevered arm out over the side of their tallest building. And on a snowy day in December, we climbed up and down with one of the robots, not one of these here. We went out into the desert and we climbed a mile into the sky. Those stunts, they teach us something. I mean, we definitely learned things along the way, but they have huge value. And it's important to note that we did all of that work before Facebook and Twitter. So if you copied those same stunts, did them again today, I guarantee you viral visibility. So just do a couple stunts, whether it's a footbridge, whether one of the things we were doing this summer when everything fell apart. There's a big bridge here. Everybody knows the Tacoma Narrows Bridge. It's that galloping Gertie that they teach in engineering class. So that's only a few, like 6 miles from here. We were going to put a barge at the bottom and have our ribbon attached to the top and down to the water. And that, because it's the galloping Gertie, every engineering student in the world is going to have an association to that. Those kind of stunts have value. So, you know, they generate science, like it wasn't wasted effort, but it also would have kind of global attention. So I'm happy to chat with anybody about those things, the things that we did and the things that we didn't do.
I'm all on board with that plan. And I think that it goes along with this sort of the seed funding and the pushing up of building this institute, gaining that momentum, really starting to build up all this stuff that Bill has been talking about of we need those people. And part of it is just getting them off the starting block, giving that dream to reach for, that, you know, convincing people in the early 90s and the late 80s of that a call like this could be happening on the internet would be a pretty hard sell. You know, it's difficult to take and tell somebody we need to start building data centers. We're going to need them. Like it's too much to try and jump all the way to the vision that we may be talking about because we're so immersed in it. You know, for the day to day, you have to focus on what happens in the next year. How does this matter to me? Part of it, and that's where I think your stunts to get people rolling on the education and to dive in and to learn more of the depth and the excitement about what a space elevator can do in the future. Only then can you get that message across. But you got to start with something easy.
Well, I like Lee's. I don't know if you guys saw the chat there. Lee came up with a brilliant idea, which is instead of a footbridge in the University of Manchester for people to bounce back and forth, have a wildlife bridge. So we have a bunch of squirrels go across it, or bears go across it, or something, and you know, we would have an instant audience for that, and then we could tell people, well, it's a you know, new material that's measuring the density of the hooves of the deer. You know, I mean, we could really do something with that. So I like the thinking. What we need to do is expand this line and figure out who can do it. Now, I have a basic rule in my organization. Everybody who works with me knows there are some really, really fantastic ideas out there, but if they don't have a champion, they don't count. So I'm just putting the challenge out there. Join Isaac and jump out there and take on the challenge of trying to figure out how to do a footbridge. That would be really great. And I used a footbridge just as an example. It could be any type of, you know, show and tell with the new material, 2D material. But you know, we need somebody to jump in and say, "Oh, I could probably run that. That'd be fun."
Okay, for the sake of sanity, let me relinquish control and pass it back to Lee. And I'll probably talk to everybody on the screen in the next 2 or 3 days. So back to you, Lee. You got it.
Thank you so much. As we close out the day, I'm going to turn it back over to Tim Chrisman and Lila Gislason to make the summary remarks for the day.
Thanks, Lee. I think this panel was an excellent way to wrap the day up, because here the talk around what's next, what's now, and how do we prepare for success merged with what's tomorrow. And that is something that probably everyone on this call struggles with. Tomorrow, we look years in advance, sometimes to our detriment, when our families ask us what we're doing. But being able to bridge the gap between the rest of society, those not super early adopters, and giving them, hey, here's your training plan for a reskilling certification. You can do that for the next so many days. How this footbridge, this, demonstration projects, and that's a challenge for us within the community to tie back to tomorrow and now and here. How can we take what's needed for a space elevator and make it work now? There's been a number of conversations about this is the largest project that humanity's ever undertaken. I would argue against that. We have 50 billion devices connected to the internet right now. And 1 second after I finish this, we will have another 200 connected. We have a living organism in the form of a connected network of devices that we made. We can learn the lessons from that, and that's part of what I think Bill's message is the cyber workforce build out could have been better. But let's take the lessons from humanity's last mega project that we just kind of stumbled into, and we're like, it'll be like the telegraph, which is kind of what we did, and sort of build from there as we, go into the future, making that accessible for the rest. So thank you for being here. Tomorrow we're going to continue with wild, ambitious projects, and we look forward to seeing you. We'll see you tomorrow.